In this video, you're going to know the properties of tangents of a circle, and then use those properties to find missing measures in a circle or within a circle diagram. The three main properties of a tangent. First, the tangent itself, tangent lines, intersect circles exactly once. And informally, this could be described by just kind of skimming the edge of the circle. So in this example, this diagram over here, line or ray R and S hit the outside of the circle just the one time, intersecting it, making those tangent to the circle. The second property, tangent lines and radii, plural for radius, are always perpendicular, meaning they intersect at a 90-degree angle. Radii come from the center of the circle. So look back over this diagram here. This right here is a radius. That's a tangent line. Therefore, I know that this angle is going to be a right angle. And the same thing over here. It's going to be another radius, tangent line, S. It's going to be another right angle. The third property is that two tangent lines that intersect outside the circle have congruent lengths. And specifically talking about the segments from the point of intersection to the point of intersection of the circle. So in blue, I'm going to draw these two lines intersect outside the circle at this blue point. That means from here to here, this length is congruent to this length. So if that is x, this is also going to be x. Now those three properties of tangents can be used to find missing side or missing lengths or missing angles within a circle diagram. For example, we have this diagram here. They're asking, what is the measure of angle CAX? CAX is right here. I know that AX is a radius. I know this is a tangent line, making CAX a 90-degree angle due to property number 2 that I wrote up there. Tangent lines and radii are always perpendicular. XBC, the measure of that angle, well, it's the same exact definition. You have a radius, you have a tangent line. I know that's going to be a 90-degree angle, just like this one up here. Third question, segment CA is equal to or congruent to segment CB. CA is right here, CB is right there, and they intersect outside the circle. They're both tangent, so property number 3 says that they're going to be congruent. Now we have 4 pictures here with all with tangent lines and radii and certain angle measures to find. You're going to find the missing measurement in each figure. So in this figure here we have 2 circles, and this line RS is tangent to both. And in red, I'm going to color in these 2 lengths. They are both radii. So therefore, I know from property number 2 that these are both right angles. Now, the picture, even though it has 2 circles and a line, tangent to both, it actually creates quadrilateral. And in previous units, we talked about quadrilaterals having an angle sum of 360 degrees. And I know that 3 of them have actual measurements. You have 90, 90, 101, and V, the missing angle. So that's my equation. If the angle sum is 360, that's going to be equal to 101 degrees plus 90 degrees plus another 90 degrees plus our unknown V. Combine your like terms. 90 plus 90 plus 101 is going to be 281 degrees plus V. Subtract 281 degrees from both sides. V is going to be equal to 79 degrees. So we use the fact that the radii and the tangent lines are perpendicular, and we used quadrilateral angle sum to find the missing angle. In this diagram, we have 2 tangent lines here intersecting outside the circle. So we can use property number 3, which says that 2 lines that are tangent intersecting outside the circle are automatically congruent. So AB is congruent to AC. We're missing angle X. I do want to note that BC is not a radius, so that's not going to be a 90-degree angle there. It's just a chord. But this does create a shape of a triangle, which is isosceles. And isosceles triangles have 2 congruent angles opposite 2 congruent sides. So you're going across from the side lengths. So across this side length here, that angle is congruent to that angle. So the 2 arrows that point to those 2 angles, those angles are automatically congruent because it's an isosceles triangle. So if that angle is X, this one also has to be X. And I know a relationship relating all 3 angles. Every triangle has an angle sum of 180 degrees. So I have 3 angles that add up to 180 degrees. That makes my equation X plus 28 degrees equal to 180 degrees. Now I have one equation with one variable to solve. So I can add like terms. 2x plus 28 equals 180 degrees. Subtracting 28 degrees from both sides. 2x equals 152 degrees. Divide both sides by 2. X is going to be equal to 76 degrees. The last example is a circle with a tangent line AB. OA is a radius, so I know from property number 2 that this is going to be a right angle, tangent intersecting a radius. We are given this angle, 41 degrees. We're looking for this angle here, X. Now, this has made a triangle, which we talked about in the previous problem. Triangle angle sum is always 180 degrees. And I have 3 angles, 2 of which I know, 90 and 41 degrees. And you add the X, and you get a sum of 180, which creates our equation. So 90 plus 41, 131 degrees.